Hello everybody and welcome to a new video about Chemi Project. Today we are going to talk about testosterone, which is the next molecule that we are going to explain. You already know that each week I'm going to explain a different molecule. Many of you will associate testosterone with strong and have a lot of muscle. Well, in a way, yes, it's right. This is a hormone that it's found 20 times more in quantity in men than in women. Testosterone has his name by testes. So yes, it's normal associated to men. And next, with another molecule, sterol, normally also associated with muscles or steroids. Testosterone has this name like steroids of tests. It was crystallized for first time in 1935 from the bovine testes pulse, and they thought this is an steroid, and we have taken from the testes. Then put the two words together and make one single word: testosterone. Only 5 years after discover how synthesized easier the testosterone and the crystallization, these two gentlemen won the Nobel Prize in chemistry. So let's continue. First, here you have the testosterone card. Here it is. You can see that it's full of hexagons and have also any pentagon ring. These are carbons, which can remember you to cholesterol. In fact, it's because cholesterol it's a precursor of testosterone. It is because testosterone is a precursor of testosterone. The body changes cholesterol and testosterone is produced. It's just want to say that I forgot to explain what I should explain from the beginning, the functional groups of testosterone. Since I am an organic chemist, so let's go here. Testosterone. Here you have a alkyl group. See the arrow. Testosterone also has a ketone group and a group, together with a double bond, a alpha 1,4 unsaturated ketone. This type of structure has interesting in chemistry. Further, testosterone has 1, 2, 3, 4, 5, 6, and 7 chiral bands of carbon that are the little triangles over here. We have already said that testosterone is produced mostly in the testes, and also generally in adults about 20 times more in men than in women. The amount of testosterone in men is around 632 in adult, as compared with 32 nanograms per deciliter that are in women. As I said, it's a steroid, and testosterone has similar structure to other molecules. Here is the structure of testosterone, and the molecules that are similar are almost with the same skeleton structure. This kind of skeleton is really common in steroids, and and come from the terpenes biological synthesis. Cortisol, which is related with nervous hormone, for example, and others like to hormone cholesterol and also to estrogen, which it's that we explain in another video. We will explain. As we continue biologically, in the first month of pregnancy, testosterone has a peak in the case of children, and it causes the formation of the reproductive organs over 3 months of pregnancy. And in the stage of childhood is not so important, but in adolescence produce all the changes that are related with men. The typical smells of teenager, it's responsible of the generation of the muscles and hair around the body, and something else like a magnification of the trachea. Testosterone activates the genes inside of cells like cells that are called sterol cells, stroll cells, that are found in the testes, and activate a gene for the production of sperm. After medical use, testosterone is a hormone, so therefore this is necessary. The normal use in medicine are related with recover the normal levels of testosterone, but be aware to improper use, especially to increase muscles. It also has bad things. First, we can have liver problems, and then it is normal because it's metabolized in the liver. It is generated in the taste, and the liver is responsible for destroying it. So we force to the liver to work more than normal. Also, it is related with hair problems, so be cautelous, please. And the testosterone that it's prescribed by the doctor, I imagine because it is not totally pure, and because seems other hormones like estrogen might cause lets you grow the breast. So be careful. Finally, I will add some problems more, like it's the acne. So testosterone have bad things, like I said before. Hair problems, increases of the teeth, and some other effects like acne. To the chemical form, it won the Nobel Prize in the 1939. First because it is a mitigation of normal use, and when its reproduction was discovered or invented, that it was not about casting 100 million of bobbins each year. A lot of scientific progress was made. Then, 5 years after discovering its synthesis, won the Nobel Prize. Now, let's talk about the biological synthesis activity. As you can see here, this is the circle of the skeleton of the cholesterol. And from cholesterol, with some enzymes, enzymes, we can remove the alkyl chain. With other enzymes, we can oxidate the adding an alcohol. We can continue the oxidation from the alcohol to ketone, and then we can reduce it again to alcohol. But this time, first we remove two carbons that right now are not there, and then we change the chirality. First have the R chirality, and right now we change to S chirality. This means the triangle there it's different. So now we oxidize it from the alcohol to ketone, the other alcohol to ketone, and we change the double bond of the position. That is easy to make with enzyme. I have explained a route. Exist others. Here you can see they have so many different routes. But in the end, it generates the testosterone. Now we are going to explain one of the chemical synthesis that we can make in one lab. Here there is a Journal of Organic Chemistry of 19, exactly the year that I was born. Here, at the synthesis from the beginning, this guy, it's a ring of 6 members that have one keton and double bond, and in addition one 5-carbon ring fusionated with one ether that have also one alkyl. And after submitting to the reactive, the double bond it's reduced. During the second reaction, by adding a curious catalysis of cobalt and also boron, was added a cyanide in the skeleton of the structure. That is cool. Cyanide normally is related with the gas chambers in the Second World War, and also with another kind of poison. But in organic chemistry, it's a functional group that it's not really bad. It's not necessarily bad. So let's continue. And then we submitting the next step by sulfur trioxide pyridine complex that basically it's a primary pyridine with aromatic rings of X member and with one nitrogen atom together with sulfur trioxide linked by the nitrogen of the pyridine. And this compound in dimethyl sulfoxide and the one solvent that it smells really bad, the triethylamine, we remove the terbutyl methylsilyl ether and we add one oxime. Well, the oxime in the compound number 12 it's oxidated, okay, but well, by employing beach. NaClO, and we make a cyclic. We make the compound number 3 that it's cyclic by employing the oxime. So in other words, the oxygen of the oxime attack to the double bond and make the ring of 5 members here. It's not the most common, it's a little bit strange. But the next step, we use the nickel rane. Again, we add our pyridine with the funny name sulfur-trioxypyridine complex, and we obtain the compound number 40. In the next step, we generate a keton wherein the oxime was localized. We break the cycle, and we use the keton to perform a Wittig reaction. Wittig reaction use phosphorus for make a double bond, and we get the number 50. From 50 compound, we first add a hydrogen in palladium carbon, and we reduce the double bond that we have here. This disappears, and then we add one base, potassium hydroxide. It's employing the primary methyl and the keton, and forming a circle. Then with trifluoroacetic acid, we break the ether. We break the ether, getting the final compound. So, well, we get that this way the testosterone, and this is all. We finish here. So thank you so much for seeing the video. Don't hesitate in make comment. Make whatever you want, and alright, I will see you in the next video, and I will tell you ow. That means goodbye in my own language. So that's all. Ow. See you. Ow.